About the last one because it's not that important. So Mrs. Gershback's class, or Miss whatever, did, I mean Miss instead of Mrs. whatever. She
Because
did,
she's not married.
she's engaged though, actually.
I know, I was being a
Anyway.
jerk. I was just being a jerk.
They, after the algebra section, did what's called sequences in series. It's not that important when we do it a lot in BC. You don't do it in AB at all. So the other section to talk about are limits. We've done limits a little bit. We haven't done them in completion. I thought we should do this first because it's important. And then if we have time, we'll do sequences in series because June's going to be tough to, care. Because I know you guys, I know you barely care now.
I really don't care.
The amount that I care is
The limit of you caring as X goes to June
does
is
not exist.
That's how tiny it is.
is decreasing exponentially.
No, it just doesn't exist.
No, you are surprised.
No.
The level in which you're not going to care in 3 weeks is lower than it is now.
I don't think it can.
Yeah, no, it will be.
Can it just forever go towards zero?
Yeah, but it'll get closer and closer, but it's still not as close as you think it can go.
It's still not as close to zero.
It's
today
pretty close.
as it
Anyway.
will be tomorrow. But then that says that there's never going to be a day where we don't care at all.
I bet there wouldn't be a day that you don't care at all.
Well, there would be the first day of summer.
Anyway.
Well, there will be. The first day of summer.
There are 2 ways to look at limits, and one we've kind of already done. So the first way to look at limits is graphically, and do you remember looking at them that way in September?
Yeah, and I failed at it.
Ooh, awesome. This is actually the first topic of calculus. So in Mrs. Russo's class next year in AB, she's going to cover all of this again. In BC, we won't talk about it anymore, but you still need to know it. It's on the AP test and all that stuff. So, yeah, here it is. This kind of sets the stage and sets up derivatives, which is half of what calculus is about. And the second way we look at limits is called analytically, which basically just means algebraically. So we're going to start by just going over again how to look at them graphically. Obviously, it's an important topic since it's coming up for the second time, and since we tried to put limits within the year a couple of times. So let's start graphically. We won't look at analytically until tomorrow or the next day. I just want to make sure that all of this makes sense. So let me give you a crazy graph and let's kind of review what this means. Why are you wearing, I don't know. So I was going to try to say something nasty.
You should.
He's
really rude.
You need to set him in his place. Right now.
Oh, bless you.
While you can.
Do it while you still can, mister. Oh, see? Wow, that rhymed.
Do what while I still can? Be mean to somebody?
Yeah, no, set Jeff in his place.
Oh.
Come on, he's laughing.
Shut up, Jeff.
No.
Whoa. Oh my god. Why is that costing
Because Jeff is rude.
Jeff is rude.
Why do you guys not...
Crossing boundaries.
He's crossing boundaries.
You're not supposed to talk to your elders like that.
You're not supposed to talk to any teacher like that. So no one's
You guys are hilarious.
Steph's an elder. Steph's an adult.
What?
Sucks.
Oh.
Oh my god.
Why are we such a
Such a pie hole.
She's just here to teach it.
I'd say she's this sucks.
It's not her fault.
Let's throw this eraser at you.
Do it.
Please.
Give it to him instead. He's asking for it.
I missed this class.
We have to copy that down.
It's up to you.
Oh my god.
I don't know. Okay, copy it. Don't copy it.
Alright. I'll go with it.
What did you just sound like? You just sounded like that girl on Bravo, you know, the newlyweds first year. Have you seen that show? And she goes, pregnant one line, not pregnant.
Why is this gonna be my video?
Have you seen that commercial for that? She's crying and she's like, pregnant one.
Oh my god, you need to get out more. Go outside.
She just has a really distinct voice and you just sounded like that girl. god. I gotta bring it up. I gotta bring the video out. It's too good.
So we could do this.
Okay, hold on. I got it. Newly
Why are we doing
weds.
As X approaches.
You know what? It might be.
It's 1. 1 is nothing. 2 is.
Guys, I don't know the answer.
That was
Stop.
2 I actually think is not easy. 2 is not. No, 1 is 1.
I'm gonna slap you across the face.
I don't know.
Yeah.
No, this is nothing.
I was going
Oh, no.
This girl.
never had it.
No, seriously.
What about mac and cheese?
She doesn't like Michael's catering mac and cheese.
What?
My dad makes like really good mac and cheese.
Wait, whose mac and cheese don't you like?
I had mac and cheese
Our
yesterday.
bosses.
I never had that.
It's so good.
I'll bring some in for class.
If we're gonna be learning, we need our energy.
There it is, there it is, there it is, there it is, guys. Everyone shh. Wait, ready?
What? She sounded like a normal person.
You shouldn't just say it in a voice.
No, she just said pregnant to mine.
What?
Kick them out of the class.
All the way on the right. Is that 5 part?
What?
Huh?
Is it going to continue? Is it going
It's got a horizontal too.
I knew this.
We're gonna talk about that. Right?
Wait, is this for D? Not yet, but we'll have
This is what we've become. We're
So
shelf
good.
today.
Like E.T.
Okay.
Back to teaching.
The definition of a limit. Oh, look at that marker.
Look at that.
The limit. As x approaches some value c of f of x exists. That doesn't start with an I.
Oh, no.
If and only if the limit as x approaches c from the left equals the limit as x approaches c from the right. If that don't happen, you don't have a limit. Unless we're talking about going to infinity. And then I don't really have to look from the left and the right. So I hope.
Or else the limit is
You're killing my spirit. Ow! Are you listening? You're the only class I come to school for now.
I wrote it down.
My intro to pre-calc class doesn't do
improv.
anything. My BC Calc class is over. It's only you. It's all you are.
We
the
only have
hopes.
3 classes?
Yeah.
Wait, is that
You
if
are my
with two
hopes
Fs?
for every day. It's coming here.
And then they're
Wait,
destroyed
13
by
periods.
death.
Is that if with two Fs or if F?
If with 2F means.
If and only if.
Here, I'll put a asterisk.
Oh, I wrote that.
Asterisk.
Stupid.
If and only if IFF means if and only.
It was a joke. You're so stupid.
So.
They're not going to be able to watch this video without hearing
I know. I don't even really care
You're
if they
so
get to see it.
stupid.
Actually, only Brenda's probably the only one who would watch.
Right.
I can't focus.
Not even.
Alright. So, I think you know the answers to these already.
Yeah.
So the limit as x approaches a is what?
Does not exist.
Does not exist.
And E.
And the reason why is because the limit from the left and the limit from the right are not the same. What's the limit from the left? Negative infinity. What's the limit from the right?
Wait, as x approaches C?
A.
Oh, I was gonna say that is that's not the answer.
Okay,
You
what's
guys-
the limit as x approaches b?
1.
Excellent.
Uno.
Because the limit from the left and the right are fine. Oh, I'll put in a 2a. 2a. What is f of b?
Two.
2. Okay, so I just want you to be comfortable with that terminology. F of b means what's the y value at b? And it's at 2. Alright, what's the limit as x approaches c? Does not exist.
Wait. What is the f of b, you said?
F of b, this just means what's the y value at b? So the y value at b is 2. Because it's filled.
Oh, because it's a hole.
You
Okay.
got it.
Got it.
Alright, the limit as x approaches c does not exist
Shut up,
because the
Jenny.
limit from the left and the right are different. The limit as x approaches d. You want to say infinity. Now, books differ on this. Some books will say, some opinions are that it does not exist. Some opinions are it should be infinity as long as it's both to the same type of infinity. So I like to go with infinity.
Well, yeah.
Yeah, whatever. Because technically infinity does not exist, sometimes they'll say it does not exist.
It's weird.
Alright, the limit as x approaches infinity. Now this graph, I'm meaning it to have an asymptote. Oops. So I'm kind of trying to say this has an asymptote at say -1. So as x goes to infinity, the y value we're getting closer and closer to is -1. And as the function goes to -infinity, we're going to infinity. Yay.
As it approaches negative infinity?
Yes. So as x goes to the left,
So as x goes this way, it goes to infinity.
as x goes to the left, we go to infinity.
Right, yeah. I'm just saying. I'm just saying, girl.
Okay. Question.
That was a review.
Okay. Number 1. If f of x is this, that, and I'm going to go. I'll go cheat.
Are we graphing them? Or no?
That's kind of the question is, do we need to?
Because I need to know if any of these things are.
Okay.
Yeah, that's a lot. I don't like graphing.
I mean, I would sketch out a little graph.
I would.
That's
I don't think I'd be able to.
You forgot to put like 3 and 2. With x approaching.
Oh, thanks.
Oh,
Okay.
do you guys just have to plug in 2 for each one?
Yeah, so these are just functions hanging out. You know what they both look like. Do we necessarily need to graph them? The first one, parabola and a line. So just to kind of go through it, I've got a parabola and I've got a line. But it's only the parabola when x is greater than 2, and it's only the line when x is less than 2. So obviously they don't overlap. The question is, do they look like this? Or does it look like this? Because if it looks like this at 2, then you're cool. If it looks like that at 2, you're not good. Or is one below the other, or whatever.
It won't look like either.
Why won't it look like either?
That would look-
Oh,
Yeah, it
for-
would. They're both at 4.
X is greater than 2. That's the problem.
For the
Oh, son of a biscuit.
Jeff, it doesn't matter. We're just looking at the limit part. We're just looking at the
Swear.
limit part. It really doesn't matter.
You could have just switched like
Hey,
the greater than.
it still applies.
The question is, does it look like that one or does it look like this one? You don't need to graph it. What can you just do?
Like in a number.
Plug in 2. Plug in 2 and see if you have a matchup there.
Oh my god.
Okay, if you have a matchup, you're fine. So for the first one, when I plug in 2, what's the y value for both parts?
4.
4. Okay, so I have this point here at 2, 4, and it works for both. Now actually, this is open. You agree? I didn't make either of them equal 2, so it's open. It's going to look like that, but the limit's fine. Just because it's open doesn't mean it can't have a limit. So it's fine, the limit is 4. But for this one, I've got the same 2 graphs. There's no way if they met up at 2, they're going to meet up at 3, unless I was really tricky with the graphs, but I've got that parabola when x is bigger than 3. What y value is that going to be at?
2, 9,
9.
and 2, 6.
And then that one's going to be down at 6, doing its thing, so that limit doesn't exist. So for piecewise functions, you want to just look and see where that split is and decide that way. Is that okay? Let's look at one more for fun. You're going to love this one. We'll go j of x.
This is one hard. Ugh.
Oh, absolute value. Stop.
That's revenge for everybody.
You're laughing.
Oh.
What does that even look like? I completely forget. Is that the one where it's like 2 lines going
I don't
opposite
remember.
ways?
This
but
was
they-
on
Yeah, it's like one up here.
This
one
was
up
on
there.
the extra credit, but I didn't do it. I didn't do this one. I don't think. Maybe I did.
Oh my god.
Ah!
Can you plug in infinity? Is that possible for you guys?
Well, no, it's you can do the 2 and 3.
Is that -1 or 1 from the left?
Okay, so this is supposed to be 0, 0 from the right, 0 from the left, -1 overall. Infinity and negative infinity. So sometimes I think it's really helpful to graph the stuff if it's weird. Like this one's just so weird, that absolute value function's so odd that I would probably graph it. So do you remember what that looks like?
It's just some
It's these things, yep, and they
Why'd
just...
you put JFK?
Oh, why did I put JFK? I was thinking JK.
I didn't know if it just meant.
And then I switched. What is wrong with me? God. No, I do. I'm just being brought down by this class.
Hey, that's
Particularly the 3 in the back. Where'd the other one go? Bentley.
Where'd he go?
Remember you attracted 225. Okay, so I sometimes start with the easiest graphing part. Well, y equals x is the easiest part, so that's just a line, goes through 0, has a slope of 1. And that happens when x is less than -1. So where do I start that part of the graph?
-1, and you go left.
I go from -1, -1, that point, it's open, and I go left and down.
Oh, it's open. Ooh, tricky. Tricky.
Try. Then I get to do the absolute value thing.
How do you do this one again?
And that's going to be a line, a horizontal line at -1 until I get to 0. And then it's going to be a horizontal line at +1 all the way to infinity.
I forget how to do these ones.
Yeah.
Well, that one's just,
Circles on
it's
either
just,
end.
They're the ones that like go like.
And it's open here and here. So just as a reminder, y equals absolute value x over x. That is going to be like this and like this. Open, open. We just talked about this. Some of the times the easiest way to think about it is like plugging things in. Like if you plugged in 1, you get 1 over 1. If you plugged in 2, you get 2 over 2, 3 over 3, 4 over 4. So you keep getting 1. That's what puts it always up here. But if I plug in like -1, I'd get +1 on the top, -1 on the bottom. If I plugged in 2, I'd get -2. I'd get +2 on the top, -2 on the bottom. So I keep getting -1, -1. So that's the idea, remembering how to graph that. Is the graph okay?
how does it work if it was like 5x over 5x?
If it's
That's like,
absolute value 5x over 5x?
Yeah, like isn't that when you like move it over or something?
Then it's just going to be, I think, up at 5
yeah, okay.
and down at
that's-
negative
okay.
5. Yeah.
Well, no, they
Oh, wait.
cancel out.
It would still be
Wait,
1.
so it's-
Oh yeah, never mind. It'll still be 1.
Still
We,
be
we
one.
did this one. We did that.
Wait,
Yeah.
what was
We
it
had a
outside?
5 outside.
Okay. And that's what moves it up 5?
Yeah.
Okay.
Yeah. Sorry. Ask me a question. I give you an answer totally out of my butt. All right. So let's see. What's the limit as x approaches 0?
Peony.
It does not exist. What's the limit as x approaches 0 from the right?
1.
Yay! As x approaches 0 from the left. Yay! As x approaches negative 1.
Negative 1.
Negative 1. You are just fine. As x approaches infinity.
Infinity.
1 that way. Because this one is always going to be at 1.
It's gonna be. It's gonna go to infinity.
You're talking about what's the y value becoming? And so if there's an asymptote, the y value
So
here is
X values
staying
go
at 1.
up.
And then as x approaches negative infinity.
Negative infinity.
Yay!
I was just looking at
Okay,
what I was looking at.
that's about it.
Yay.
That's all that we have to do with limits.
Graphically. And then we get to look at the hard ones.
No.
Oh wait.
It's on
Sorry,
Thursday.
I was-
We're not starting today.
No, we'll stop.
Woo!